Hi, grade 9s. Welcome back to class, in air quotes. I made a graph here of a couple lines, and I want to do a little bit of review at the same time that I'm going to be teaching you something new. So we're going to have a little bit of everything here. So let's look very closely at these two lines. I did them both with this blue pen, and you'll notice, of course, everybody recognizes that these are called parallel lines. Of course, parallel lines are like the tracks, not the tracks, but the rails that the train goes on. They're parallel, they never meet. These lines will never cross each other. That's really the definition of two lines that are parallel. But I want to get their equations because we have learned enough over these last couple of weeks that if we have a graph that looks like this, we can see that the y-intercept, I don't know if you guys can see it because of the lighting, but it's -13 right there. So the y-intercept is -13 for L2. And the slope we can count because I've clearly marked off these points. And to get slope of a line that's on a graph, the fastest and of course the easiest way to do it is take 2 points. I'll pick these two. You can pick whichever two you like. And I count rise, which is 2, 1, 2, and I count run, which is 1. So we know the slope is the rise over the run, which is 2. And you can pick any 2 points you want. I like to pick them close together, but they don't have to be. If you pick them further apart, of course, you would have rise 4, run 2, but 4 over 2 also equals 2. So it doesn't matter which 2 points you pick. And once you know the y-intercept and the slope, then you know the equation. So I'm going to write the equation right next to this line. -13 is called the coefficient of the x. And the b, oops, I made a mistake. The coefficient of the x is the slope, silly me. And the y-intercept is called the b. And that is the equation for L2. So remember in this topic, every time you have an equation with 2 variables like this, you know it has a matching graph. And if I give you this, I expect you to be able to draw the graph. And now we've learned that if I give you the graph, you should be able to create the equation. And that is the equation that works for this particular line. I want to do it again for L1. So I look for the y-intercept, which is where the line crosses the y-axis. And again, it's hard for you guys to see that number, but it's -5. So I'm going to write over here L1. The y-intercept is -5. The slope, let's count. Rise 1, 2, run 1. Slope is 2 over 1, which is 2. And so L1 has an equation, y equals, we put the slope attached to the x and the y-intercept. And that's the equation that matches with L1. But of course, and it shouldn't come as a big surprise, because these lines are parallel, they go up at the same amount of steepness. That is, if you were on a toboggan riding down the hill, these hills would be equally steep because they have the same slope. They both have a slope of 2. You can see it right here. They both have a slope of 2. And this is a fact. Parallel lines like L1 and L2, they have the same slope. Now be careful. The same slope merely means that if you count rise over run, you would get the same numeric value, the same number that if you counted rise over run on his partner parallel line. It doesn't mean the equations are the same. Of course the equations are different because the lines are different. But the part that is the same is the slope. Okay? This is a fact. You have to learn it, you have to know it, you have to understand it, because it's going to come up a lot in future. I'm going to do another question from a different perspective, but the same idea. This time, I'm going to start with an equation. As you can see down here, L1 is y equals a quarter x plus 3, and I'm going to graph that because we just finished learning that it's very quick and easy to graph a line if it's in y equals mx plus b form. The b is the y-intercept. We put a dot at 3. To graph it, we simply count slope. Rise 1, run 4. So that's what I'm going to do. I'm going to rise 1, run 1, 2, 3, 4. Put a dot. I'm going to do it again. Rise 1, 1, 2, 3, 4. Put a dot. I want my line to stretch this way, but I also want it to stretch to the left. So I go down 1, 4 to the left. Oops, 1, 2, 3, 4. That doesn't count. Down 1, 1, 2, 3, 4. Maybe I'll go one more. Down 1, 1, 2, 3, 4. Down 1, 1. No, I'm out of room. And when I connect these, I get the graph. So it's a pretty quick way to graph. If you know the slope, it's fairly quick to graph. And whenever you graph a line, you always put the equation beside it. So I'm going to write y equals a quarter x plus 3. And I'm calling this guy L1. So I did that. And now I'm going to take L2, which you can see right here, y equals a quarter x minus 1. And you'll notice, you guys, the 1/4, which is the slope, is the same. I'm going to graph L2. I put a dot at minus 1, which is right here on the y-axis. I rise 1, 1, 2, 3, 4 to the right. Rise 1, 1, 2, 3, 4 to the right. Let's go the other way. Down 1, 1, 2, 3, 4 to the left. Down 1, 1, 2, 3, 4 to the left. And when I connect it, you can see visually how the fact that the two lines, this is L2, and his equation is 1/4 x, take away 1, have the same slope, and they're parallel. So that's why I'm illustrating for you a couple of times the idea that if two lines are parallel, that's only going to happen if they have the exact same slope. Now, I have a couple lines over on this graph that I drew in red, and of course they're obviously not parallel because they're hitting each other when two lines intersect like that. Parallel lines would never intersect. These guys do. But what I'd like to do, not so much get the equation. I don't need the equation. Let's just focus in on the slope. And remember, this is, I'm calling L3. To get the slope, I don't want the equation. I just want the slope for now. The slope would be, well, you see all the dots that I've made. You can pick any two that you want that are on this line, which I'm calling L3. And I'm going to count to get the slope of the line L3 by counting rise 2, so that's the rise, 1, 2, and then 1, 2, 3, but it's to the left, so it's negative. And that's the slope of this line. I write M for slope, and then I put an L3 right here. And this number is the same thing, of course, if the negative was up. It doesn't matter where the negative is as long as you have one, but it is a negative slope, which makes sense because the line is going down. But look what happens when I take the slope of L4. This is the fourth line on my paper. I'm going to pick 2 points down here so that we can count very clearly. Rise 1, 2, 3. Let me write it right here. M of L4. Rise 3, 1, 2, 3, and run 1, 2. 2 to the right. And notice it's going up. That's why I have a positive slope. I rose, I went up, and I went to the right. And those are both positives. Rise a positive number, run a positive number. Now look at these two numbers, and you'll notice a pattern here. The slope of this line is negative 2/3. The slope of this line, it's like you flipped it, but they have opposite signs. These numbers are called negative reciprocals. I'm going to review the idea of a reciprocal with you in a minute. But I want to make a point, because when you look at this picture, I'm going to tell you it's a true fact. These are perpendicular. This is a 90-degree angle. I drew it that way, so I'm telling you that it's a true fact. But look what happens when you have two lines that are perpendicular. Their slopes are, of course, their slopes are not the same, but they are what's called negative reciprocals. Very interesting. Let's try that again. Same idea, and then we'll look at these kinds of numbers more closely in a minute. I have two more equations here that I'm going to graph. Let me show you them. You see, this one says minus 3 over 2x, take away 6. Now we know, because we've been studying this for a while, that the slope of this line, the slope of L3 is negative 3 over 2. But the slope of L4 is positive 2 over 3. These are negative reciprocals where you flip it and opposite signs. So watch when I graph these, how I'm going to get two lines that certainly will look perpendicular, but I know for a fact that they will be because their slopes are negative reciprocals. So I'll begin with y equals, sorry, I'm just trying to adjust this so you can see it. And the lighting is a little funny. I'm sorry. I'll make that that doesn't work very well either, does it? So we'll keep it on, give it a sec to focus. Right there. Okay, it's not great, but I'll write on it so you can see it. L3 is negative 3 over 2x minus 6. This is what I'm going to graph. Y equals negative 3 halves minus 6. So I'm going to go to the B, which is negative 6, on my graph, and I'm going to put a dot at negative 6. You can see the graph. It's down below the x-axis, negative 6. The slope of this line is negative 3 over 2. So what I'm going to do is I'm going to go down negative 3. I'm going to go down 1, 2, 3. That's the negative 3. The 2 on the right means, on the bottom rather, means go 2 to the right. The run is positive. Then I do it again, down 1, 2, 3 over 1, 2. Now I'll go up 1, 2, 3, but left 1, 2. And I'm going to make a short line so that all of our pictures don't crash into each other. But basically, that's the graph of what I'm calling L3, and the equation is negative 3 over 2x minus 6. So now, hope I made it long enough. Let me do one more point. Up 1, 2, 3 over 1, 2, 1, 2, 3 over 1, 2. It's always better to make your lines long. We always want them to be really nice and long, and we always put arrows on the end. So now I have a better line, okay? So that's the first one that I did down here. Now I'm going to take L4, which is y equals 2 over 3x plus 1. And let's graph that, and you're going to see it's going to be perpendicular to this guy. Watch. We begin at positive 1, and the slope is rise 2. The slope is rise 2, and then run 3. So I start at 1, I rise 2, I run 3. I rise 2, I run 3. I'm going to go back and go down 2, 3 to the left. Notice it's not on the line. That's okay. I'm counting very carefully. Down 1, 2, left 1, 2, 3. I'll do one more. Down 2, 3 to the left. So now you can see that all of these red dots I'm going to connect line up. I'll do one extra one here. And I get a beautiful straight line, accurate, because I'm using points that are really very accurate. By counting slope, you're accurate. And you can see that I have a 90-degree angle here, okay? I do not know that little spot. It's not on, I can't read what it is, but I don't care where they meet. I care that when they hit each other, they form a beautiful 90-degree angle. And remember, a 90-degree angle is when you have like a T or an L shape. I'm going to draw you two lines over here in green. And I'm going to make these lines intersect. They cross each other. But you can see it's not a nice T or L shape. So these angles that are created are not 90 degrees. It's only when you have one line and then the other line and they make this beautiful T shape. So this is what a 90-degree angle looks like. And when this happens, it gives us information about these slopes. So that's the idea we're going to practice. We're going to state our conclusion, okay, over here. Our conclusion. Number one, if two lines are parallel, two different lines parallel, they have the same slope. They're totally different lines, but they rise with the same amount of steepness, or they could be going down and have negative slopes, but they would be parallel and their slopes would be the same. And the second conclusion is that the slopes of perpendicular lines, if you have two lines and you know they're perpendicular, are negative reciprocals. Okay, so we're going to practice this idea in a minute. Here's a picture of what perpendicular lines would look like, or they could be going up like this, but when they meet, it's a 90-degree angle. So these are perpendicular lines, and their slopes are called negative reciprocals. So let's investigate this idea, but first let's be more familiar and comfortable with some of the language that I've been using. Okay, let's just practice the idea of reciprocal for a minute. You guys remember reciprocals. You learned that back in elementary school. The reciprocal of a fraction means, and this fraction, in case you can't see it that well, is 3/2. The reciprocal of that fraction, you know, you just flip it and you get 2/3. The numerator and the denominator switch places. If your fraction is a negative fraction, this is 7 on top, 4 on the bottom, there is a negative sign here. I don't know if you guys can see it well. When you take the reciprocal, the 4 goes on top and the 7 goes on the bottom. I still leave my negative sign in the numerator. When a fraction is negative, it's your choice. You could put it in the numerator, you could put it in the denominator, you could even put it way out front. I always personally keep it in a numerator. So if I have a fraction that's negative, the reciprocal is still negative, I just flip it. What's the reciprocal of 2? Well, remember 2 really means 2/1. So the reciprocal would be 1/2. And you guys have had to take reciprocals. For example, if I said to you, what's 3/5 divided by 8/11? Your teachers all taught you, you don't divide, you take the reciprocal and you multiply. Correct? Oops, 40. My bad. That's one of the places you've used the idea of reciprocals. So I'm just reviewing the language. 3.5, if I ask you for the reciprocal, well, you can't tell me till you change it to an improper fraction. 3 times 2 is 6. 6 plus 1 makes 7. Oh, now I can tell you the reciprocal. It would be 2/7. So of course, this is review. Remember, -5 is the same thing as -5/1. And so the reciprocal is still a negative fraction, but it's 1/5. That's regular reciprocal. Now in this topic, we're doing something called negative reciprocals. Again, I don't think you can see the word, so I'm going to highlight it. A negative reciprocal means do exactly what we did up here, flip it. But it also means change the sign. So if the original is positive, 3/5, the negative reciprocal means negative 5/3, okay? That's called the negative reciprocal. If the original is negative, for question B, then to take the negative reciprocal, you're going to flip it. The 7 goes on the top, the 4 goes on the bottom, and it changes. It becomes positive. Negative in the world of mathematics, you guys all think it means there's a negative sign. It doesn't. negative really means opposite. The negative of 7 is -7. The opposite of 7 is -7. The negative of -8 is +8. It means the opposite, okay? So when I have 5/8, the negative reciprocal would be 8/5 negative, okay? In this next question, I have a fraction that's -2/3. If I say to you, what's the negative reciprocal? I'm saying, what's the opposite reciprocal? It's 3/2, but it's positive. Okay, so you see how they pair up. You not only take the reciprocal by switching the numerator and denominator, you also take the opposite sign. So this is the idea of a negative reciprocal. So let's use the idea now and just talk about the slopes of lines. Let's go back to thinking about lines. I'm always going to have 2 lines. I'm going to tell you the slope of the first line, and you are going to tell me the slope of the second line. Okay, so if I give you the equation, and I say I've graphed a line, and I know that he has a slope, when you look at this equation, you say, well, I know the slope of L1. The slope of L1, because I know the trick, it's simply 1/4. Great. So what would L2's slope be? Now remember, these guys are, and look what I did here. I said L1, and I put these 2 lines. This means is parallel to. I'm going to shut this light and see if I can improve it. I'm really sorry for the quality of this picture. It does not seem to be cooperating today. That's no good. I know you're having a hard time seeing it, so I will continue to write over it. All right, I'm giving you 2 lines, and I'm telling you that line 1 will be parallel, I promise you, to line 2. I don't have a picture, you just have to believe me. You have to imagine it in your brain. But if I tell you the slope of one of the lines is 1/4, then the slope of the other guy also has to be 1/4, because parallel lines have the same slope. So if his slope is 1/2, guess what? So is his. If this guy's slope was -2/3, so is his buddy's. Parallel lines have the same steepness, the same slope. Question B. The first line is described with this equation, L1. Okay? It's -2/3 x minus 8. L1 is parallel to L2. What would the slope of L2 be? Well, since they're parallel, because in this situation all of these pairs are parallel, if L1 has a slope of -2/3, then L2 has a slope of -2/3. It's a pretty straightforward idea. They have the same slope. So in this question, no matter how I give you the information, if you know one of their slopes, you automatically know the other one's slope. If the first line has a slope of -4/3, then the slope of the second line is -4/3. In the final example, I'm going to be a little sneaky and take you back on a little bit more review. I'm not going to tell you the slope of L1, but I gave you the equation. Do you remember how you get the slope just by looking at the equation? This is a situation where the slope of L1 will be -a/b, the a over the b with the extra negative. So you can quickly figure out that the slope of L1 would have to be a/b with an extra negative. And if that's his slope, then guess what the slope of L2 is? Because they're parallel, that's his slope also. So the idea would be over and over again, I give you the slope of one, and you use these 2 new ideas to give me the slope of the other. I'm going to do another question right here. This time, my two lines, L1, look what I wrote here. See that little symbol? That's because I'm a lazy teacher. I'm too lazy to write L1 is perpendicular to L2. So in math symbols, you can write this same thing out like this. So that's what this means. The two lines that we're talking about in these four examples are perpendicular. So remember, if I were to draw a picture, they would make a 90-degree angle somewhat like these lines up here. That's a situation. So if you know one slope, you use it to figure out the other slope. So what I wrote here is the slope of L1 is 3/5. Tell me the slope of L2. It is the negative reciprocal. So everybody should be thinking in their brains, 5/3, but negative, because you make it the opposite sign. If L1 has a slope of 4, what do you think the negative reciprocal of 4 would be? Well, don't forget 4 means 4/1. The negative reciprocal is 1/4, opposite sign. Now I have a question over here. Again, I'm a little sneaky. I'm also doing a little bit of review. This is L1. And I want you to tell me his slope. And then, of course, I'm also going to want you to tell me L2 slope. So this is a situation where you want to use the A, which is -3, over the B, which is -7, and then there's an extra negative. So altogether, the slope of L1 is -3/7 because there was a negative here. So therefore, the slope of L2 would be the reciprocal and the opposite sign. If that guy's negative, he's positive. That is the negative reciprocal of that. And the last example, if I give you the slope of L1, well, I didn't. You have to figure it out. But we all know, because this is y equals mx plus b form. So here, the slope is -5. Since they are perpendicular to each other, the other line will have a slope that will be the negative reciprocal. So again, this is over 1. You flip it, and because this is negative, this one becomes positive. So this is really more information for you about slopes of lines and how there is a relationship if you have a situation with parallel lines or perpendicular lines, that you actually know something about their slopes. The last exercise that I'll try, and this will be the last one, take a minute, is you got to fill in the blank. This is much easier, right? I mean, it's the same idea. I give you the slope of the first line, and then I tell you the two lines are parallel. If L1 is parallel, then the slope of L2 and the slope of L1 have to be the same. You get the same number. But if they're perpendicular, and the first one is -1/2, then the other one is positive 2/1. Sorry again for the quality of the video. It's horrific. I'll keep rewriting these. Okay, a couple more examples. If I tell you the slope of the first line is going to be 2, and I tell you the two lines are perpendicular, then you say, okay, well, if I know his slope, that's a clue. Now I know this guy's slope. It's the reciprocal, which would be 1/2, opposite sign. It's the negative reciprocal. In the fourth example, I said the slope of the first line is 1. But L1 and L2 are perpendicular. So what will this guy's slope be? Well, it's the negative reciprocal. This is a funny one because 1 is the same thing as 1/1. That's 1. And if you flip 1/1, You still get 1 over 1. But this is positive, so the negative reciprocal becomes a negative 1. And then the last one, which says if the first line has a slope of, sorry, if the first line has a slope of negative 5 over 3, oh, and the second one has a slope of negative 5 over 3, fill in the blank. L1 is blank to L2. Are they parallel or are they perpendicular? And because the slope is the same, you would fill in the word parallel, or if you're lazy like me, you can do that. But you can put the word if you want. Okay, so when you go to the content section of the, you will find the homework. The homework is based in the textbook. There are solutions provided. You do not hand this in. But when you're finished, the teacher will take it up with you in class. So you should go back to the contents page to find the homework.